Professor Belfrost's science class is back.
Hi, welcome back to my channel, and today we will discuss about some problems that I have prepared for you. Okay, so here are the problems that I from some exam papers that I have. Okay, we have three questions as usual. We have physics, mathematics, and chemistry problem. Please take a screenshot. So this is the first slide, mathematics and physics problem. This is the second slide, chemistry problem. I want you to pause this video and give a try first before uh, you watch the explanation. And if you find there are something that seem to be wrong, please let me know. Okay, so here the first problem. Okay, so number one, it is about physics, right? And we are given um, the value of E, which is actually a vector quantity, not a scalar quantity. So it has a direction, which in here is represented by I hat, okay, which means that it moves along the x-axis. Okay, so by substituting all the given information, that we will have this new equation, which is E equals 1.0 times sin 10 10 cube t I. But we also know that F equals ma, which is in the case F equals q times E. Yeah, because this is about electric charge, electric field. Okay, so F equals QE, and A, as usual, if you have known, this is dV over dt. So we can just create a new equation, QE equals m dV dt. So dV equals QE over m times dt, and we can take integral from both sides, and uh, integral of dV is v from 0 to v, which is v itself, and q over m integral the e dt, which is relative to t from a value of 0 to the maximum value of t. But when the maximum speed, but what is the time that will give the maximum speed, as the problem wants to find? It is when the time is half the period, right? So because we know that period is 2 pi divided by omega. So 2 pi divided by omega divided by 2, it is pi over omega. Therefore, we can just substitute all the values given, and there is it. So we have the v equals 2 meter per second. And that's the answer for the first problem. Second problem. Okay, so this is a mathematics problem, and it is also about calculus. Okay, so we have the problem right here, and we have to rearrange the expression given. So here the rearrangement that I've provided. So dy over dx equals, we factor the expression, the sub-expression. So we have 5 extracted from 5y plus 2, and we extract 2 from 5y minus 2. And we can create a new expression as shown in the slide. Then let's us rearrange the equation. So the terms of y will be on left side, and x term will be on right hand side. Okay, so let's do a little manipulation, little algebra as usual, and we can find this form. This is a very basic one. I think I did not need to explain it to you. And we find, after solving as what I shown here, so we found that a equals minus 5 quarter and b equals 5 quarter. Now we have a new simple problem, simple equation, which can be written as 1/25 times 5 quarter times the integral of um, 1 over y minus 2/5 dy minus uh, 1 over y plus 2/5 dy equals integral of dx, which we can actually notice that there is a form like uh, dy, which actually dy minus 2 fifth and dy plus 2 fifth actually have the same result. So dy, because the constant have a zero derivation, right? Okay, so therefore we can write the previous term as below as shown, which is in a learn form. So 1/20 learn y minus 2 fifth minus learn y plus 2 fifth equals x plus c. Yeah, you need to add the c here because this is independent integral. By noting that we have the a property of learn a minus learn b equals learn a over b, then we can rearrange and rewrite the expression as shown in the slide. And to make this simpler, we can multiply the numerator and denominator with some value, which in this case is 5. So we can rewritten it as 1/20 times learn 5y minus 2 over 5y plus 2 equals x plus c. But it is given in the problem that f0 equals 0. So by substituting this value, we can find the c. C is 0. So now we can um, solve it much easier. And we have new expression, which is the absolute value of 5y minus 2 over 5y plus 2 equals the exponent of 20x. Then, because we are about to find the limit of fx with x is to minus infinite, then we can write the expression as shown in this slide. But we know that the limit of e to the 20x with x comes near to minus infinity, it is equals 0. So because of that property, we can rewrite the expression as shown below. And then we know from the property of limit, so we can extract the 5, factor it out, and we can write as shown in this slide. There we have limit fx equals 2 of 5, which is 0.4. That's done. That's for number 2. Number 3, chemistry. Actually, this time we are going to discuss about the concept of exothermic reaction, endothermic reaction, about the entropy and the equilibrium constant and the entropy too. Okay, so maybe this is quite a confusing concept. Maybe you need to recheck your book again. You need to read it again, and I'll give you that time. Okay, so let's analyze one by one option that is given. So with A, okay, we know that with an increase in temperature, according to the Le Chatelier principle, then the equilibrium will shift to encounter that change. So for an exothermic reaction, which releases heat, an increase in temperature favors to the reactants, then reducing the equilibrium constant. And a positive entropy change of the system with increasing temperature also contributes to the decrease in value of K. So uh, this is true, right? This is this my previous explanation supports the option, so A is true. With B, then as we know that when temperature increases, then the equilibrium will shift to alleviate that change. And for endothermic reaction, which absorb heat, then a rise in temperature will favor the product, then increasing the equilibrium constant K value. Then the decrease in entropy change of the surrounding with increasing temperature also aids in the increase of value of K. So B option is also true. How about C? So when temperature increases, according to Le Chatelier's principle, the equilibrium shift to counteract that change. And for an endothermic reaction, which absorbs heat and increasing temperature favors the product, and increasing the equilibrium constant K. And the negative entropy change of the system with increasing temperature also contributes to the increase in the value of K. So uh, actually, these oppose the given option, okay, the given description option C. So option C is wrong. How about D? Okay, so when temperature rises, the equilibrium shifts to elevate chains, and for an exothermic reaction, which releases heat, an increase in temperature will favor the reactants and reducing the equilibrium constant K. And a decrease in the favorable entropy chains of the surroundings with increasing temperature also will aid in the decrease of the value of the constant, the equilibrium constant K. So D is also true. So the correct options are A, B, and D. That's all. And we're done with today's discussion. So here inspiration for you today. A very good quote, I think. C.S. Lewis once said, "You can go back and change the beginning, but you can start where you are and change the end." Okay, you can't go back and change the beginning, but you can start where you are and change the end. Okay, so start act from now. Okay, there's never uh, any too late for you to start with. Okay, start today and keep progressing. Thanks for watching. Here's to the list. Subscribe, give a like, comment, and share this video to your friends. My class will be on every Tuesday and Thursday. And that's it. Keep watching. Be thoughtful. Goodbye. See you.